Welcome everyone. In this video lecture, we will solve a numerical based on negative feedback voltage amplifier which consists of a common gate based series shunt feedback. Okay, and this problem is from the Microelectronics circuits book. Okay, so here there is a negative feedback voltage amplifier which based on the common gate amplifier. Okay, so in the question, what is the question? For the given circuit, so there are some circuit which are given. So I have already made the circuit. So this circuit is given here where R1 plus R2 is much greater than RD. Okay, using a small signal analysis, find the expression for the open loop gain A V naught by Vi. So first thing that we have to find, that is our V naught by Vi, that is our open loop gain. Okay, open loop gain we have to find, and then after we have to find the feedback factor beta, that is our Vf by V naught. Okay, Vf by V naught. So here there is the term Vf, I am writing here. This one is our plus of minus Vf. Okay, this one is this voltage across the resistance R1 is our Vf. Okay, so now then after we have to find the closed loop gain. Closed loop gain, that is our V naught upon Vs. Okay, V naught upon Vs, the closed loop gain, that is our V naught. I am highlighting that part. Closed loop gain. Okay, closed loop gain V naught upon Vs. Okay, and we have to neglect it R naught, that is our channel length modulation we have to neglect. So no need to worry about the resistance R naught. And also we have to find the approximate expression for AF. Okay, so that we will do it later. So the very first thing, this circuit is given. Okay, and this voltage across the R1, the voltage across the R1 is our Vf, and voltage across this one is V0, Vs, Vi. Okay, so first of all we have to find the open loop gain. So for that purpose I have made the modified circuit in which this one is our gate in, and this one is our drain, and this in we can say the source in. Here also you can write the drain in, and this one is your gate in, and this in is our source terminal. Okay, so the very first we have to find the gain A V naught by Vi, open loop gain. So we are starting with the determination for the open loop gain. Okay, so open loop gain. Okay, that we have to find A equals to V naught by Vi. Okay, so this one is our MOSFET. Okay, so first of all what we will do, we will draw a S equivalent model for this MOSFET. So as we know, for the simplification, what we have to do, for the AC signal model of that particular MOSFET, suppose this one is our gate, drain, and this arrow one is our source terminal. So the AC equivalent model for this device will be simply, we can make like this. Okay, where this in is our gate. I think you know this concept, gate drain, and this one is our source terminal. So source, and this one is our plus of minus VGS, and this one is our GM VGS. So this one is just the AC equivalent model for this one. Okay, this one is the AC equivalent model. Okay, means what I am saying, this one is the transistor MOSFET. So the model will be like this. Model will be like this. Okay, model will be like this. Okay, so that we have to use in this circuit. Okay, for the open loop gain, now we are not thinking about the feedback part. Okay, so then after what we will do, we have to concentrate on this circuit. Okay, so we have to make the a small signal model. So first what we will do, first we have to make the gate, drain, and source. Okay, and source is nothing but simply connected to vi. So just I am saying this voltage is a plus of minus vi. Okay, so plus minus, we can write it vs. Okay, and this one is our gate in, and this one we can say the source in and drain in, and the S equivalent model we are making. So this should be our what, gm times of vgs, but here the gate in is connected to ground, so we can make it ground. Okay, and this voltage, as we know, this voltage vgs. Okay, this voltage is vgs. Okay, so and this one is drain, and to drain one rd is connected, so we have to make one rd here, rd, and this one will be the v naught. Okay, this one is our v naught. So we have to find the value of v naught upon vi. Okay, here we have written vi, so better to write vi. Okay, we have to find a v naught upon vi. Okay, so now this one is the circuit. So what we will do, suppose some current, I am saying some current. Okay, and some different color, say this current I am saying I naught is flowing like this. Okay, and this one is nothing but simply what, I naught. Okay, this one is I naught. So what we can say, I naught is nothing but simply gm vgs. Okay, I naught is same drain current gm times of vgs. Okay, and one more expression we can write, the I naught, this I naught across this resistance, if this one is the resistance and this one is grounded 0 volt, and I am saying this one is v naught and some resistance rd, so this current is also I naught. Okay, so I naught can be written as 0 minus v naught upon rd. Okay, and both are same. This is equation number 1 and equation number 2. Okay, we are finding the open loop gain first, so we can write a gm vgs equals to minus v naught rd. Okay, because equation 1 equals to equation number 2. Okay, so we can write, because both the expression are same. Now see, gm and vgs can be written as vg minus vs equals to minus v naught upon rd. Okay, now vg is what, vg the voltage, this gate voltage is nothing but simply we can say 0 volt, and vs voltage is nothing but simply vi volt. Is it okay or no? vg vg is 0 because it is connected to ground. Okay, and vs this voltage is nothing but simply vi. Okay, so we can simply say this value will be 0, and vs is nothing but simply vi. Okay, so one more line we can write like this, gm minus vs, or one can write 0, vs is nothing but simply what, voltage across the source in is vi, so we can write it vi equals to minus v naught by rd. Okay, so I can write minus gm times of vi equals to minus v naught upon rd. So this minus minus cancel out, so we can write v naught by vi. V naught by vi is simply gm times of rd. So this one is our expression for the open loop gain. Okay, so first part is over. So now a, the value of a I can write here We have to write here A equals to V naught by Vi, the open loop gain for the common gate amplifier is Gm times of Rd. Okay, so this one is the first thing that is asked in the question one. First thing, the open loop gain. So we have find the value of open loop gain. Okay, so we have not used this feedback circuit. Okay, now we have to go for the feedback factor everything. Okay, so now we have to find the feedback factor. So we have to take care of this picture. Okay, so for this purpose, okay, we can draw a line here. Okay, now we will do for the next part. Okay, so for the next part again, this one is the circuit. Okay, so the first thing that we have to do, we have to draw the AC equivalent model first. Okay, so AC equivalent model for the whole circuit. Okay, but here we have some also some supply source is there. So what we will do first, we will try to draw the transistor. Okay, so this one is our, simply write like this, and this voltage is our what, Vs. Okay, clear. So first you write this end is our gate. Okay, this end is our drain, and this end is source. See, first, sorry, this one is our drain, source, and this point or this whole is our gate terminal. Yes or no? Now there is our some Vs is there. Okay, so what we can do, plus of minus, and this one is our Vs. Okay, I'm making it blue color. Vs. Okay, now see, from drain, and for the AC model, thus VDD will be grounded. For the AC model, this VDD will be grounded. For the AC model, VDD, the supply will be grounded. Okay, clear. So in the first previous case also, VDD we have grounded, so we have make like this. Okay, so now once again, so I'm just from drain, it is one resistance is there. Okay, so this one is nothing but simply your RD. Okay, and we are taking output from this point, that is our V naught. Okay, so make it V naught. Clear, this point is V naught, this point is V naught. Now see, drain and gate are connected through the resistance R2. Drain and gate is connected through a resistor R2. Okay, through a resistor R2. I'm just highlighting this gate. Okay, better to, this gate is this resistance, and this drain is connected to gate, and drain is connected to a resistor. So we have used a resistor and we have connected. Yes, yes or no, this one. Now see, R1 is connected to gate and it is grounded. Okay, so no need to worry, this one will be the grounded, and this one is simply R1. Okay, and this voltage is nothing but simply your plus of minus Vf, feedback voltage. Okay, so okay, I am also highlighting this part. Okay, gate is connected to ground. Okay, so gate is connected to ground here. Clear. So we are just making the first the model, AC equivalent model. Okay, it is a very good problem. Okay, then what we can say, this voltage is nothing but simply your what, plus of minus voltage, feedback voltage VA, that we have to determine. See, in the question Next part is our feedback factor beta, that is our Vf by V naught. So that's why Vf and V naught will be there, and this will be what, Gm times of VGS, Gm times of VGS. So now this one and this voltage we can say this plus of minus that we know VGS. Okay, so this one is the small signal model of that particular circuit. Okay, now we have to find the feedback factor. Feedback factor, that is our what, beta. Beta equals to Vf upon V naught. Vf upon V naught. Okay, so here what we observe that there is a resistance R2 and there is a one more resistance R1, and this voltage is our drain voltage, is our nothing but simply V naught, and this voltage is simply our Vf. Okay, so we can simply write the expression for the Vf H V naught, this voltage into simple network concept R1 by R1 plus R2. Okay, so we can write Vf upon V naught, that is our simply our feedback factor beta R1 upon R1 plus R2. Okay, is it clear or not? Feedback factor, so we have considered this part only. V naught by Vf we have to find. So we have written like this voltage is V naught and it is connected here. Okay, then Vf equals to V naught times of R1 by R1 plus R2. So that part is clear. So the feedback factor already, this is also asked, feedback factor Vf by V naught. So we have also calculated the first part, the open loop gain that we have calculated. Okay, open loop gain, this one A of the common gate. Then feedback factor beta. So beta we have calculated V naught by Vf by, sorry, V naught. Okay, beta R1 by R1 plus R2. Okay, now the third part. Third part is what? Find the overall closed loop gain. Now we have to find the, this calculation we have did for the what, feedback gain Vf by, okay, feedback factor, okay, a feedback gain, that we have this one for the feedback factor. Okay, I'm writing here. This one is our feedback factor, factor, that is our beta. So beta already calculated, so I'm writing here beta R1 upon R1 plus R2. Okay, that part is also over. Now we have to find the value of what, closed loop gain. Closed loop gain, in the question they are asking the value of closed loop gain. Okay, so I am writing here closed loop gain we have to find, that is our AF. Now AF is what, V naught upon Vs we have to find, V naught upon Vs we have to find. So for this purpose what we will do, the same circuit we will use. Okay, so now how we will find the value. So for this purpose what we can say, I am saying, look this circuit. Okay, say this current is I naught. Okay, I am saying this one is I naught, and this current is say GMVGS current is going, in this current I am saying I1. Okay, so what we observe that if we apply KCL, I am writing here, apply KCL. Okay, KCL at node D, drain point. Okay, drain point. So how many currents components are there? See, one at this one is at D. So one current is, I am saying I naught is going this current. Okay. Then after one current is going this side, that is our GM VGS, and now this current, that is our I1. Is it okay? Let's see. One current is, okay, take some different color. I naught is there, so I naught current is this one. GMVGS, so GMVGS is there, okay, and I1 is there, so this I1 is there. So these three current is going, okay. So now what we will write, the expression for this one will be what, the KCL equation, KCL. So total incoming current we can write it I naught, I naught equals to I1 plus GM times of GM VGS is a current source. Okay. So I1 plus GM VGS. Okay. Now we have to write. Okay. So I naught value, we can simply write, this one is I naught. So I naught we can write 0 minus V naught upon RD. Okay. So we can write I naught equals to 0 minus V naught upon RD. Okay. Then I1, I1 is what? This current. Okay, so this voltage is V naught. So V naught and this one is 0. Means see what I am saying. This one is our R1 and R2. And this voltage is V naught and some current is flowing I1. Okay, so I1 is nothing but simply V naught minus 0 by R1 plus R2. Simple. Okay, so can we write simply V naught upon R1 plus R2 plus GMVGS, because it is there. Okay, simple equation. So now next, okay, what we can write, minus V naught by RD minus V naught upon R1 plus R2. Okay, we are taking this term in the left hand side, so minus V naught R1 plus R2 equals to GM, and we can write as VG minus VS. Okay, this VGS can be written as VGS can be written as VG minus VS. Is it okay? Clear this one? The VGS, VG minus VS. Okay, GM times of this. Then what we can write? Minus, if I am taking V naught common, 1 upon RD plus 1 upon R1 plus R2. Is it okay? Then GM. Now see, what is the value of VG? What voltage? VG. This voltage we have to find. Okay. VG is nothing but simply VF. Okay. From this figure, what can say? This VG value is nothing but simply this feedback voltage. Okay. This voltage VG is VF. Yes or no? VF is nothing but simply the potential across the VG. Okay. So VG we can say is nothing but simply our VF. Gate voltage is nothing but simply this feedback voltage VF. Okay, Vg equals to Vf. So Vg, we have calculated Vf equals to V naught R1 upon. Is it okay or no? Very simple concept of network. Okay, so what we can write instead of Vg, or simply write small, we can write as V naught R1 by R1 plus R2. Okay, and minus Vs. Okay, Vs. So Vs is our simply voltage equals source voltage. So you have to make like this. Now there is relationship between V naught and Vs. Now we have to find. Okay, is it okay now? Vg. Why I am writing this one? This Vg is nothing but simply Vf. Okay, so we can write directly this. Okay, from this expression. See, this Vg is nothing but simply Vf. Okay, and Vf we have calculated like Vf V naught times of R1. So this one is V naught Vg. Is it okay? So now we have to solve this one only. Okay. So what we will do, if I am taking common minus V naught, can we write 1 by Rd, directly I am writing 1 plus R1 plus R2, and if we take this V naught common and minus V naught, so what we can write minus Gm R1 by R1 plus R2. Oh, sorry, in this one plus, take minus V naught common, so Gm R1 by R1 plus R2, and this one is minus Gm times of Vs. Okay, so this minus and this minus will be cancelled out. Okay, so the expression will be written as V naught by Vs, simply Gm upon, okay, we have to solve this one. Okay, so first write one more line, 1 by Rd plus 1 by R1 plus R2 plus Gm R1 by R1 plus R2. Okay, so now next what we can write, Gm, and if we take common, means take the LCM, R1 plus R2 times of Rd. Okay, so first one we have to write R1 plus R2 plus Rd plus Gm R1 Rd, Gm R1 into Rd. Okay, now one more line we can write V naught by Vs. V naught by Vs we have to find. So can we write Gm R1 plus R2 into Rd. Okay, at the top it will come, and this one R1, and I am taking R1 plus R2 common. Okay, from this one, so one can write 1 plus Rd by R1 plus R2 plus Gm R1 Rd upon R1 plus R2. Okay, so now this and this will be cancel out, so this value will be Gm Rd. Okay, and 1 plus C, and one more relationship there, R1 plus R2 is much greater than Rd. Okay, so this value will be very high. Okay, this expression is given. Okay, so this value is very high than this one, so this value is nearly equals to 0. Okay, I am writing directly, so this will value will be nearly equals to 0. Okay, because R1 plus R2, so the simplified equation will be GMRD by 1 plus GM R1 RD by GM R1 RD by R1 plus R2. Okay, this one is our, we can say, AF. Okay, AF. So this one is the simplified expression for AF. Okay, we have removed this one because in the question it is clearly mentioned R1 plus R2 in the very first line. R1 plus R2 is much greater than RD. So RD upon R1 plus R2 is nearly negligible. So we can eliminate the thing. Okay, so this one is the thing. Okay, and we have to find one more part is there. Okay, one more part is there. What is the overall what question? Find the approximate expression for a beta greater than 1. Okay, for a beta greater than 1. Okay, so what we will do for this purpose, what we can do, for the yeah, some space issue. Okay, one more. I will try to complete in this. Okay, okay, means also that AF we have calculated here. AF already calculated. Now this AF is there. Okay, so we can write the GM Rd into R1 plus R2, okay, and R1 plus R2 plus Gm R1 Rd. Yes or no? Now if we take Gm Rd common in the both the cases, now I'm going to simplify this one to an approximate value. Gm Rd upon R1 plus Rt, and I am taking Gm Rd common. So it should be R1 plus R1 plus R2 upon Gm Rd. Is it okay? So this and this will be cancelled, right? And Gm Rd is nothing but simply the gain, open loop gain. So this open loop gain, Gm Rd, the A value. A value is nothing but simply GMRD, which is very high. So it very high, so it should be nearly zero, we can say. So the simplified expression of AF can be written as R1 plus R2 by R1, that is our 1 plus R2 by R1. This one is our simplified one. Okay, for A beta much greater than 1, the last part. Okay, so for A beta much greater than 1, okay, the value will be 1 plus R2 by R1, this one. But this one is the generalized formula V naught by Vs. Okay, that is our AF. Gm Rd by 1 plus Gm R1 Rd upon R1 plus R2. So this is all about this question, and this question is very good problem, very good question from the microelectronics book. So I have covered the all the values, okay, for this problem. So this is from the microelectronic circuit book. If we go from the speed book, it will you will get the same question in example section. Okay, exercise section, not example. It is not solved by in that book. So this is all about this question. So thank you for watching this video. Thank you.